out.
Yeah, just let me share. So able to see my screen, right? Yeah, I created one thing actually. So when I try to query it using Athena, right, I'm getting an option error like this. I created two things. Both are doing the same error.
We go up. So you can see now, before you run your first query, you need to set up a query result location in S3. Click on edit settings here.
Edit settings.
Right hand corner.
Oh,
Right hand
edit
top corner.
preference.
No, settings, edit
Okay.
settings.
Okay.
Choose a location here.
So it can be anything, right?
Yeah, for now it can be anything. Yeah, save it. Editor, yes. Run this query now. Okay, now there is issue with your job location or crawler. It is not error. Okay. So do one thing. Yes, open this location. Temp simple data. Here you have no report, nothing now. No files are there.
I created this says history.
It is a folder now. It's not a file.
Oh, let me check. Yeah, here it is actually. This is the file.
Yeah, but if you go on your table location, just go on the table.
Yeah.
What is the location there? Expand the location column. See, I have told you in the recording, actually, you cannot point to the direct file, okay?
Okay.
You have to point in a folder. So move the say .csv into a folder, then you can point it.
Okay, got it. And also one more thing, actually, I created this job, glue jobs, visual jobs. So I'm getting some additional things.
Show me.
So this is a folder is automatically getting created. So I created this thing actually. So this is my visual job I created, but this is creating as a .py files. By default, it's creating to this bucket actually. So for real time also, it will be by default creating in bucket all the scripts. Whatever you do, it will be coming here.
No, I didn't get your question here.
No, I created actually a visual ETL visual job, glue visual jobs.
Show me the job.
Yeah.
Go on the job.
Yeah, so I created like this job. I ran from like converting paraquat normal that same file to paraquat file. So I'm done with this. But what I see is right. I'm seeing some in bucket. It's creating one bucket with this name and it's creating some files like this. Whatever I created the job, it's creating a visual job.py. Here I'm creating visual job with an ETL job. The same code has been converted like a script actually. So I'm just asking in real time also same way it will be creating a script and those script only will be migrated to production like that.
See, in real time, actually, yes, same scripts will be created as I've told you. If you click on the script box here, you will be able to see the script, actual script here. If you click on the script box, not here, in the glue part.
Yeah, here also it's produced.
Yes. So there are ways to migrate this. Obviously, script goes scripts gets deployed and all those things. You are not going to drag and drop in UAT and productions. Okay, and as I told you, more oftenly, you will not be creating the visual jobs for the productionization.
Yeah, right. Okay. Yeah, that's all.
Okay, other two has kind of busy, so we'll start with the Apache Spark. Okay. So today we are going to learn a bit deep about the Spark. Okay, so if we come on the Apache Spark actual documentation. This is what they have. If you go in programming guides, quick start, see options like quick start is there. Okay, RDDs, accumulators, podcast variable. This we are going to see. Data frames examples we have already seen. Okay, SQL we have seen. Okay, then PySpark examples we have already seen. Then there are and others like R examples, MLib, like those are kind of not in this course. Okay, and you can completely ignore those until you want to learn machine learning and all those things. Now, if you see here, what I'm going to discuss today is some more details about the Spark. Okay, so as I mentioned in the earlier part of the course that we have kind of Spark structure. This is how it looks like on top. This is like a Spark offers to you, and this is a kind of a architecture that Spark follows. Okay, so it's a master slave architecture where we have multiple worker nodes, one cluster manager and one master node. Okay, all these things are actually connected. After that, we have number of jobs. Okay, so what is number of jobs in Apache Spark? So jobs is nothing but the program we write. Okay, so if I open this, can be my one of job. Okay, PySpark demo or not this one. Oh, just a second. Let me open the correct folder in that case. PySpark. Okay, now if you see, I have a PySpark job here. Okay, very easy one. Here it is. Yes. Okay, this is the one. Yeah, I'm basically creating a job. This is a job. Okay, complete. Basically, if I say in very simple terms, a complete piece of code that achieves something for you is called a job in in these programming languages. Okay, so this is one of the jobs. Okay, so how we decide the number of jobs in Spark? Okay, and how it actually matters. So if you, let's say you have a project, okay, and in that you want to do multiple things on you have a requirement where you want to achieve multiple transformations, multiple things. So you have two options. Okay, either you can code all those options, all those transformations in a single job. Okay, or you can divide that into multiple jobs. Okay, so a program can look like this also, where we have already only 66 lines of code, or it could be thousands of lines of code, and this is a single job. So what we say in Spark actually, the jobs are high level user defined units of work. Okay, typically consist of one or more Spark actions. Okay, that means we'll have some activities on the job. So how we decide these numbers? Okay, and what are the benefits of converting your huge jobs into a smaller ones. So first of all, let's say I have thousands of line of code running, okay, and my job fails on line number, let's say 990. Now, if I have to test the job or fix the job, I'll have to, rerun all the lines, and then it will start going running further lines. And let's say next time it fails on line number 1200, and next time it fails on line number 1800, and next time it fails on line number 1850, something like that. So if I have a very huge job, chances of being failed of that, chances of getting error are more. And even if I have, I'm not committing anything. All the processes that all the lines, let's say my job first time fails on line number 900, my 899 rows were executed successfully, okay? But I haven't saved the result of those things, and my job got errored out. In next iteration, again those 899 rows have to recalculate their values. They re-executed themselves, and again job got failed on line number 1199 or something like that. Okay, and this process goes on continuous ways. So we are re-executing kind of the lines which were successful in the first iteration itself, but we have to rerun those because our job is not completing in a one go. So, and obviously it is hard to debug those things. Okay. So that is why it's suggested that you derive number of jobs. You divide the one huge job into multiple transformations or multiple jobs. Okay. So let's say you want to do some calculations. Take few calculations and save the result in some location in one job, and then trigger next jobs, or trigger next parallel jobs, like that. I mean, whatever suits you better. Okay. Then it also says that if you create too many smaller jobs, okay, if you create too many smaller jobs, that is going to, again increase the complexity. Okay, how it is going to do so? It's going to impact the overall performance by, complexity. Okay, like you'll have to compensate for scheduling. Like you have, let's say, you create 100 of jobs instead of one job. Then you have to schedule those 100 of jobs. Every time the job starts, it will need its own time to start the cluster and conveying those messages, because it works with the master and slave nodes. It will need its own time to accumulate the results, and so creation of too many small jobs is also not recommended. Okay, so this is what we say in the number of jobs in Spark. Okay, how to decide this? Now there's no fixed number like that. Okay, you should create a 10 jobs, or we should create a 15 jobs, like that. But what our intentions is, if you have too many calculations in a single unit of work, that is also not acceptable. And if you have too many units itself to that is just doing one transformations, that is also not acceptable. Be a bit wise. Try to divide your job some bit logically, and get your job done in optimized way. Okay, so you have any questions here?
So if my job failed, right? So how it will be taken care from next step application? So you're telling while passing itself, like a count is equal to first one. I'm saying my thing. Okay, so that will be a one job, and another will be getting the count of that particular so and so count. So two jobs are completed, but third one step is failing. So I can use both values if I rerun the job.
No. In AWS Glue, at least no. You'll have to restart it from the top.
Top only, right? Okay.
Okay. I mean, see, if I say very simple, a job is nothing but a program. Okay. It is asking you to do not create a too huge program, and not create too many also. Okay. Divide logically. Save your output and use it in the next one. Okay. Then we have number of tasks in Spark. Okay. Let's format this. And we have task in AWS. Just a second, this is better actually. I simply enhance this. Okay, then we have task in Spark. Okay, a task, as per the definition, it's the smallest unit of work that Spark executes on its individual partition of data. Okay, do not get too confused here. Okay, so when we store the data on some location, okay, and mostly here we are talking in the case of Hadoop or Big Data Hadoop or native Spark. Okay, this is not a Spark, like this sheet is not directly in touch with S3 or a cloud work. Okay, it is mostly talking about a native Spark. That is also true for cloud Spark. Okay, be it on Databricks, be it on AWS Glue, be it on Azure Synapse, be it on EMR, all everywhere essentially concepts are same. So whenever we store the data, okay, so we do not store data mostly in a single file, okay, because those files have some limitations. So it says if you have, let's say you have 10 files of 10 MB each, then basically we are going to start 10 tasks in the Spark. Okay, when the job is going to be started, okay, when the driver program submits the request to executors, it is going to start 10 tasks. One task is going to solve its own partition. Okay, a task will be launched for every partition, and a particular task is going to compute the results for single partition. Then the results at the end are going to be accumulated and given back to the driver program. Okay, so same thing we are saying here. When we submit the job, based on the number of partitions our data has, according to it, number of tasks will be started. Okay, now by default, as it says, Spark calculates the number of tasks automatically based on the number of partitions. You can obviously influence this by repartitioning your data. Repartitioning basically means, let's say if you have 100 partitions, you can join them and make them 10 partitions. Okay, you can reduce the number of partitions. So again, same concept comes here. If you have a single partition, okay, if you just have single partition of your data, in that case, only one task will be launched, and the particular task is going to take its own time to complete the execution, and it's going to burden up on your obviously Spark cluster. How? That let's say this driver program submits your request, okay, on a GB of file. It's a single partition, and the particular it will be assigned to a single worker node, okay, because we have single partition only, and it will start only one task at the executor, and this task will take its own time to execute this, let's say 10-15 minutes, and it's going to give the results back to driver program. So you'll have to wait 15 minutes to complete your PySpark job. Okay, now if you divide that file into 100 MB each, like same 1 GB file, you divide that into 100 MB each. In that case, we have 10 partitions now. Now we are going to start on these two executors at least 10 tasks. Okay, if the hardware capacity permits. Okay, this is also a true part. If the hardware capacity permits, which mostly does. Okay, so no, it actually does not. Executor single starts two tasks at the same time. Okay, on this Glue's worker nodes. Okay, so here again, task will be started in the multiples of your partitions. Okay, so it may not be 10, but let's say we start with 4 tasks. So 4 tasks will be running at the parallel time. They will complete the work. Okay, and then 4 more tasks will be started for other things, and then likewise, 4 tasks will complete your 10 partitions individually, and then it will get results back to driver program. See what I'm trying to say? If you have one file, only one task will be started. If you have let's say 10 partitions and you have 10 tasks available with you, 10 tasks will start working on the 10 partitions at the same time, and they'll complete the operations and give back the results. If you do not have the capacity, okay, and let's say you have just 4 tasks, in that case, first 4 partitions will be processed and they will be stored. Okay, then next 4 partitions will be solved, and likewise it will be solved. Okay, so this is how we work with the partitioning of the data. Now again, same thing. If you have a single partitions, that is also not optimized because you are not completely using the parallelism in the Spark cluster. Only one worker node or one task will be executing at the same single at some point of time. Okay, but if you have too many partitions, okay, as the last line says again, it's essential to strike a balance between too few and too many tasks. If you have too many tasks as well, in that case you are creating too many small partitions, okay, and they will cluster manager will be overwhelmed in that case. Okay, it will have to let's say we create thousands of partitions. Okay, in that case this cluster manager will have to accumulate thousands of the output coming out from this worker nodes, and then it will be able to give it back to the driver program. So you might be finishing your computation here quickly on the worker node, but in that case this cluster manager or this driver program will take its own time to accumulate and join the results and give it back to its requester. Okay, so we have to understand that again we have to choose a optimal number of partitions as well. Now optimal number of jobs, optimal number of partitions, you will understand this by your own experience in the project. Okay, like if what is the size of your cluster that you are working in your project, what is the data you have, what is the pattern of your data you have in your project. It depends on all those things. You cannot say there's a right answer like we have to create 50 partitions or 40 partitions or 100 partitions. Okay, there's no number for that. Okay, so you cannot say in an interview that 50 partitions are the best partitions or 100 partitions are the best partitions. You have to give him this expression only that neither too few is good, neither too many is good. Then you have to give the reason as well why too many is not good. In that case, accumulation will take time. Okay, and too few is not good because you might not achieve the complete parallelism and they will take its own time. Okay, so you have to convince the interviewer like this. Okay. So yes, if you have any questions on the number of tasks.
No, Jalaj. So we don't have any formula kind of thing, right? Because I just
there's no formula. Otherwise, it would have been very easy.
Okay.
This is where experience comes into the picture. Someone who understands the data size, someone who understands the cluster, someone who understands how much time he has. It's all depends on that.
Yep.
That's why data architects are paid in like 50 lakhs, 60 lakhs packages. It actually goes on that level. Okay, it's not data engineers work to optimize on this level. Optimization is might be a part of your day-to-day work, but on this level, okay, based on reducing the number of tasks or optimizing the number of tasks or optimizing the number of stages. Stages actually can be done by developers, that is for sure. But optimizing the clusters is not a solo work of a developer. It has to be coming out from some architect level.
Yep.
Okay, then number of stages. So before we understand the stages, okay, we have to understand few more things. Move this. What's this? No, I don't want to save this file. Let's see. There is a concept of DAG. Directed acyclic graph. Please bear with the spellings. Okay, I think I'm right, but not 100% sure. Now, what is this? See, forget about Spark for now. Okay, let's talk in SQL mode only. Whenever we submit a SQL, a plan is generated. Okay, I hope you know about this part. Whenever you submit a SQL, a plan is generated that how is query is going to perform. Whether it's going to filter first, whether it's going to perform a join first, whether it's going to perform a group by first. Okay, I mean it's very obvious that it will be filter first and then join or group by or whatever the conditions. Okay, so reducing the data first and then other things. Now in Spark, if you see this code, okay, how will you generate the plan for this? You are running this query individually here. Then you are running this query individually here. and then you are having a filter clause here, you have a show here, and you have a SQL again here. Okay. So in Spark code, we are not submitting a complete query. Again, in SQL, you mostly submits the complete query. Okay. Like in SQL, you cannot say that you submit a query first and save the result somewhere and then use the result later in the other query. I mean, definitely you can use staging tables. That is a complete different concept. But in a single query, you cannot divide a query. You'll have to use inner queries. Okay. So whenever you submit the SQL code, all the inner queries, all the CTs, all the group operations, join operations are solved, and an optimized plan is generated by the compiler. So how can we achieve that in Spark? So to do that in Spark, we have directed acyclic graph. So whenever you submit a Spark program, this DAG is created that basically optimize your all actions in your code. Okay. So when I submit this query, my directed acyclic graph is not only going to consider for this query, it is also going to consider for next filters and next operations. But how it does that? It does based on two things. So basically in Spark, we have two kind of things. One is transformation. Okay. And second is actions. So transformation basically means you transform your data, you make changes in your data. Okay. Actions basically means to view or store the data. Okay. So let's talk about transformations. So in here, if I show you this code, let's talk about this one only. So in here, okay, if I do filter, this means I have a data frame called Spark data frame or Spark DF. I say filter based on size equals to M. Now this is a transformation. That means I am transforming my data in Spark DF and saving the result somewhere else. Okay. Same way, if I say select these columns only, maybe I have 100 columns, but I'm selecting only 4 or 5. This is again a transformation. Okay. And if you remember from the last week, all the examples that I gave to you, okay, all the examples that I gave to you, like filter, changing the column, adding the column, all those are transformations only, where you modify your data somehow. Okay. So when you do all these transformations, Spark does not take any action. Okay. So we can write it like this. On transformation, Spark does not take any actions. Okay. And this phenomena is called lazy evaluation. This is called lazy evaluation. This basically means a Spark is like when you like, let's say you have this complete program. A Spark is like, okay, you want to select something, I'll do it later. You want to filter something, I'll do it later. Okay. It's basically like you do all your transformations. Then whenever you take some action, then maybe I'll calculate it for you. Okay. Right now, it doesn't need any operations from my end. And this is what we call as lazy evaluation. Okay. Now what is actions? Now what are actions? Okay. Actions, as I've written very, in very easy language, it is when you want to view, store the data. Okay. That means this show here on line number 49 is an action. This show here on line number 54 is an action. This operation on line number 55, where I'm trying to write my file on a output location, is an action. Okay. So whenever you want to view the data or store the data is action. Now how these two things relate to Spark lazy evaluation. Okay. So understand this part again. If I select my columns here, okay, on next line, Spark is going to take action and it's going to execute this statement. Okay. So whatever the plan is, this DAG is going to generate, it's going to based on this particular query. Then on next line, it's going to see that it needs to filter something. Okay. On again itself, I have action. So Spark is only going to pick up this line of code and going to generate a DAG for this, and it's going to execute the DAG itself. Okay. And again, I have a show, that is an action. Again, I have query, and then I have a output location. Okay. In contrast of that, if I show you this code, so what is happening here is I am doing some window operation. Okay. I am doing some with column operations. I am doing some drop. I am doing some more operations. Let's forget about the sprint schema. Okay. Let's comment this as well. Then 5 to 6 operations I have done. Okay. 7 to 8 operations I have done. So what will happen? All these operations will be collected in a single DAG, and a best optimized plan will be generated. Okay. So what we gather from this is, if we want to generate a optimized DAG, okay, if we want to generate optimized DAG, we should not use actions very frequently in our program. If we use actions very frequently in our program, we are not allowing a Spark to create a proper DAG for us. Okay. If we do not use show, count, or store operations, okay, let me write it for you. It basically show, count, or file writing. Do not call these operations very frequently in your Spark programs. Trust me, this is one of the easiest and the best optimization that you can do. Okay. So if I give example, in my last project, I had a job that was around 900 lines of code. Okay. What my colleague did, she was just junior, kind of after everything, she was, looking to get the results, like if the output is looking good or not, like after every step, showing the data frame, like after every transformation, after every join, after every group by, just visualizing the data frame, whether we are doing good or not. And the job was running for around 1.5 hours. Okay. And if you remove all the count operations and if you remove all the show operations, it was running for 10 minutes and less than 10 minutes actually. This is a huge difference for a single job. Okay. So you need to understand that write all your operations if possible, and then at the end only you do a show, count, or store operations. Okay. Only on these operations, until unless you call these operations, Spark is not going to execute those. Okay. If you want to really understand this, go on notebooks, apply these things. I mean, apply multiple transformations and do not call a show. Your job will not take even a second. It will, like, without blinking your eyes, it will complete those things. But when you call a show, then it will take its own time to solve all those transformations and put the results for you. Okay. So what I'm trying to say, like, just do a practical here. Open this folder and open those sheets that I provided to you. Let's say we open working with columns. Okay. Just execute your code, like just execute all these lines of code without show. Okay. And you will see these will get executed without, before you blink on your eyes, these will get executed. Okay. But if you call show on these things, it will take few seconds. That will give you idea that how Spark is actually working. Okay. So I'll take a pause here now. So first of all, you have to understand if you what is DAG, what it basically means, transformations and actions. Like you should clearly know what is the difference between action and transformations. Okay. And you should understand what is lazy evaluation in Spark basically means.
Yeah.
Let me know if you have any questions here.
Yeah, I understand this concept.
Okay. Now these transformations can also be a variety. There can be two kind of transformations. Okay. It can be a narrow transformation. It can be a wide transformation. So I'll open an Excel for you. Let's say we have 4 partitions. Okay. Let's say part 1, part 2, part 3, part 4. Okay. Let's say we have some colors here: red, orange, green, one more red. Okay. Same way we have something here: orange, red, black, or maybe green. Okay. Let's say we have something similar here as well on part 3. Let's say we have pink here, red, orange, and let's say green again. Okay. So now if I submit a filter operation, okay, if I submit a filter operation that I want only green data, so what Spark will do on this partition itself, okay, let's highlight this in bold. On this partition itself, it will filter it out. Okay, that means it will pick green from here, green from here, and it will pick green from here. Okay, it is simply filtering out the 3 partitions and it's not doing anything. Let's forget about the part 4. But when I call a group by, okay, let's say I say group by color. To group by, what it has to do, let's say I want to say group by and count the how many occurrences are there. Okay, so what it will do, it will check. First of all, it will have to do kind of shuffling operations. So in shuffling operations, what will happen? Let's move it a bit low. All the reds will be picked up. Okay, this got picked up from part 1. Okay. Likewise, red will be picked up from here as well. Okay, and likewise, it will be picked up from here as well. This is called shuffling. Like all the 3 partitions are read. Okay, we have to pick the required thing and we have to shuffle them and put them together. Same way, green will be done. Okay, so it will be like green from part 1. It will be like green from part 2 and green from partition 3. So this is like this operation, group operations requires some data movement between the partitions. Okay, so all the transformations that does not require any data movement between the partitions are called narrow partitions. And all the transformations that require link are called wide transformations. Okay. So you have any questions in this part?
Jalaj, your voice dropped on this white transformation. So can you repeat the definition you mentioned? So all the transformation that does not require shuffle.
See, all the partitions, sorry, my bad. All the transformations that requires data shuffling are called narrow partitions. All the, sorry, narrow transformations, not partitions. I don't know what I'm thinking. And all the transformations that need data to be shuffled from this partition to that partitions, okay, are called wide transformations. Wide basically means the operations is going to be applied on all partitions, like it's going to be applied on all the partitions, okay.
Yep.
This is the concept here, okay, narrow partitions and wide partitions, okay. We can write no data movement, and it's basically data movement is needed, okay. So if you think of examples, filter, select, upper, lower, these are narrow transformations. Group, join are your, and partitions, sorry, group, join, windowing are your wide transformations, okay. So what it says is, now I'm coming back to stages in the Spark. Stages in the Spark represents a set of transformations that can be executed together, okay, typically separated from narrow or wide dependencies, okay. So the number of stages depend on logical structure of your Spark application, specifically how transformations are organized. So all the narrow transformations that you have in your code, like map, filter, those things, are going to be accumulated in a single stage, okay. As they do not need any data movement part, they will be calculated in the single stage, okay. And all your transformations, wide transformations that need data shuffling, will need its own stage, okay. So let's say if I come back here on this actual part, let's say we are let's say first we do filter, okay, then we do a map operation, then we do a lower operation, okay. This is your one stage, okay. This is your stage one. There is an option to merge in center. I don't know why it's not working, okay. So you can basically simply select this and you can say merge and center. Let's make it up, okay. Then if you have a group operation, this is your stage 2, and when you have join operation, this is your stage 3, okay. This is how it actually works. So all your smaller transformations can be accumulated and they will be in stage 1 more or less, okay. It's not always that you will have only one stage for those. Like if you have too many if you have too many narrow transformation, then you might have 1 or 2 stages, but for these things you will definitely have your own stage. Now again, your task is to lower down the stages, okay. Now obviously your count and show will have some stages all together itself. So what we learn from this, if someone asks us in interview, suggest me some ways to optimize the Spark jobs. First thing you will say, remove unnecessary show and count operations, okay. Then you can explain him about the lazy transformations or lazy evaluation of the Spark and explain it. Then second thing you will mention the partitioning, okay. You will give him a justification by saying that if you have only single partition, in that case you will not be able to use the complete power of your infrastructure. You will not be able to get the full capabilities from the parallelism that Spark provides to you, and your job will be running for longer, okay. But on the other hand, if you create too many partitions as well, in that case, you are losing out an opportunity to optimize again, because in this case your cluster manager will have some burden up. Okay, because see, in this architecture your cluster manager is also responsible for accumulation of all the tasks. Let's say you have submitted 10 jobs and all job has thousands of partitions. That means 10,000 of partitions single cluster manager has to accumulate. Okay, in that case this is again a not a good situation for your complete architecture, and you will not have the optimized way here. Sometimes it might get stuck as well. Third thing, you can say to him, number of jobs. Divide your program in ethically good numbers. Make sure you save your data after every job executes. So if your job number 4 fails, you do not have to rerun all the jobs again. Okay. So few of the optimization options are these. So if you have any questions, you can let me know.
So when you say a partition thing, right? So the column will be defining, right?
It depends how you create the partitions. Completely. It can be based on date. It can be based on some column. It can be simple cutting of data, like you have 1 GB, you divided it into 100 MB each.
Okay. Yeah.
So as I suggest in next few slides that data handling and transformation options, I'm suggesting some optimization techniques. So minimize data shuffling. Okay. So if you can minimize the data shuffling, I mean, how it can be minimized. You cannot, let's say you have to calculate some results and it need group operations and join operations. Obviously you can not remove those operations, but what you can do, you can filter first. Let's say you have 1 GB of data and only 500 MB was applicable for that, then remove that 500 MB first. I mean, as soon as possible, remove unwanted data from your computation. Okay. Data partitioning, I have discussed how to optimize the things with the help of data partitioning. Always use partitions. Okay. There's one more use case of partition that we will discuss in the Redshift and the Snowflake part. Caching and persistent can be used. Okay, first of all, let's wait here if you have any questions.
Oh, no,
Okay. Then caching. If you see this code, okay, let's assume this, like, I'm writing some logical steps one by one. And let's say I generate a data frame here. Okay. Let's say I generate this continuous data frame here, and I might need this data frame again back in after some few lines. Okay. So what will happen? Spark might discard the results here. Okay, let's say you calculated this data frame here, and you have a huge program and you have a huge data sets. In that case, Spark might remove the results of this calculation from the caching, and when it is needed again, it will recalculate that. Okay, so what you can do in Spark, you can force this to be cached. Okay, you can force this to be cached in Spark calculation. Okay, so what will happen when next time you need this information again, Spark is not going to recalculate that. Okay, it is as simple as that. Okay, so you can think like, you are working on some puzzle, and whatever you already know, you are storing it back in some location, but that location is very small, and expensive as well. So you cannot store everything there. You can only store few important things only there. Okay, So you have to let go a few things as per your priority. If you have this particular statement as a priority that you think that you might need again multiple times or single time in my code, and it will optimize my execution, then you have to make sure that you cache that. Okay. So how we do it, or what are the options that we have here? For, I mean, you got the option of what is caching. It is persisting the intermediate results in a Spark program until unless your program is finished. Okay, and it is forcing, like we are forcing that intermediate results to be stored there until unless you finish your job. And as the next line suggests, you have to be mindful when you cache large data sets. So you are like on 4 GB of cache memory, you are not supposed to cache 10 GB of data. Okay, that will obviously not work.
And also, what about multiple caching? So we have multiple actions, things, right? I mean transformers, right? So multiple caches is fine.
Yeah, you can do multiple until unless you are filled, like until unless your cache is full. As I mentioned, you have a small area where you can store your results. Okay, but it is small. You have to prioritize your results.
Yep.
Then we have some types of caching. Okay, so let's say you have data frame df that you want to cache. You simply say cache, or you simply just say dot persist. Either one of these things. Okay, not two, either one. Then you provide the label of caching. This is basically storage label memory only. That means you are saying store my intermediate results on cache memory only. Okay, store the results on cache memory only. Second option is you store the results memory only serialized. Okay, this basically means you are converting your results into a serialized format that will take some less space, but while reading it, it will need some more time. So when you have time constraint that you know that you cannot wait, in that case you will say memory only. This means it is deserialized objects are stored, but they will need more space. Okay, they will need more space. So basically, in layman language, if I explain you, if you have a Word document that you want to read, if you store normally on your hard disk, it will take, let's say, 1 MB. But if you compress that and then store, it might take 250 250 KB or 400 KB, like that. Okay. But if you want to read that, obviously it will take some more time. You will have to decompress that and then you can read it. So same thing is here. If you directly store it on memory only, it will take more space, but it will be faster to access. If you say memory only serialized, it will be less space, but it will be more time to access that part. Okay. Then you have one more option of memory and disk. Here you get your data cached both on cache memory, and if it is not fitting into cache memory, the rest of the data is going to be cached on your memory, that is RAM. Okay. And this is also, this is called data spilling in the Spark, and obviously accessing the spilled data will be slower one. Again, you have the same option, memory and disk with serialized. You can store the data in a serialized format. It will take more time, but it will take less space. Then you have the option of disk only. That means you are freeing up your cache, but you are storing your data on completely on disks. Obviously, it's going to take some more time while you reading it. These are the 5 options available for you. So you can also mention these options in your interviews by giving some examples. Okay, referencing to some examples. So you have any questions here?
Oh, no,
You're all good here?
Yeah, good.
Okay, I request you to go through the documentation of these things, or to have more information. I'll request you to do that.
Yes.
I have tried my best here, but I'll request you to go through the official documentation or some blogs here on this topic specifically. Okay.
Just a quick question, like in real time, right? So which one is like catchy or persistent catchy? Which one you prefer more? Like performance?
See, on AWS Glue, I never do it any of these.
Oh,
It's
okay.
just for interviews.
Oh, okay. Because it is money for catchy also. They'll we need to pay something. Is it like that?
No. It's not like that. It basically on this cloud things are more optimized now.
Okay.
These are all when you have your own architect, when you have own infrastructure or own cluster.
Hmm.
Maybe on EC2 these options might be there. See, I mean, see, this thing. You're already quite experienced. What they ask in interview and what we do in real time is
Yeah,
quite.
right.
Okay, so I have shared this PPT with you. You can refer it. If you have any questions, you can let me know. And yeah, we will meet tomorrow.
Jalaj, I have one question actually. Two questions.
Yeah, yeah.
Yeah. So regarding this Athena, right? So I'm creating external table means where this table will be storing. So normally we'll be creating the table in crawler, so we can see it in Athena. Just select and start. But if I want to create the external table, I'll be using the Athena, right? So how do where the table will be saving in Athena itself, or how it is?
Table.
Yeah,
No,
create external table.
no. See, when you run the crawler now, that is also external table.
Oh,
And
external.
actually on Athena, there's no concept of internal tables. It's all external tables only.
Okay.
Okay. So basically, this concept of internal tables and external tables says when the database itself stores the data, like MySQL, PostgreSQL, these are the internal tables, where the responsibility of storage is also with the MySQL. But when you have the data somewhere else and just the metadata with the database management system, it is external storage, external tables. Examples are Hive, Athena, these things.
Okay.
And now we have this B something, yeah, B warehouse or some DBV or something like that. I don't know. Wait a second. It's B or something like that. Yeah. Bye. I am not recording. It's not equal. Warehouse name DuckDB.
Okay.
DuckDB is one of the example of external systems. This is great. I mean, you can refer some examples here.
Okay. Got it. Okay. And one more thing, now we in my error issue, right? You fixed one thing, right? Like giving the output path S3 bucket. So what is the use of it actually?
See, as I mentioned, the Glue Athena these does not store any data. So any intermediate data, any results are stored on those locations. It's all stored on S3.
Okay.
So whatever the output you are generating, it's all going to be stored on S3 only.
So output also it will be storing only. It will not just display and leave it. It will be storing. Just I'm putting select star from 10 only, right? Limit of 10. So that will be storing.
Go on that bucket and you will see it's not actually store the actual results. It's just some details, some intermediate results like that. Actually,
Okay.
I never checked that bucket inside, but it's not actually your complete output.
Okay. 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 Yeah,
Okay,
that's all.
Karthik.
Thanks.
Thanks, Karthik. Bye bye.